Alright, in this video we'll be looking at harmonic identities, which are your r sine theta plus or minus alpha, or r cos theta plus or minus alpha. So the reason we use this identities is, let's look at, for example, an equation like this. If you've got 3 cos theta plus 2 sine theta is equal to 1. There is no intuitive way of simplifying this equation to become an equation in one trig function. For example, the first thing you might think is, maybe let's divide through by cos theta, right? So that we can use the identity tan theta is identical to sine theta over cos theta. Alright? But if you do that, the problem here becomes, if we divide this by cos theta, sure, it cancels out. We divide this by cos theta, this part is going to yield the tan theta. But we also have to divide the 1 by cos theta. And so now what we have is 3 plus 2 tan theta is equal to 1 over cos theta. So we still have 2 different trig functions. So that doesn't actually work. So in a situation like this, we use what we call harmonic identities. So it means we're going to express our equation in one of these forms, either r sine theta plus or minus alpha, or r cos theta plus or minus alpha. Let's look at both of these forms. Let's start with r sine theta plus alpha. So going back to our example here, I'm actually going to rewrite this with sine theta coming first. So 2 sine theta plus 3 cos theta is equal to 1. This is the convention, because you have to have your equation in the form a sine theta plus b cos theta, when we then use the formulas that we're going to derive in a few seconds, alright, is equal to whatever constant you have. Okay, so what we're going to do, say for example, you've been told to express this equation in the form r sine theta plus alpha. And we've been told to rewrite this expression in the form r sine theta plus alpha. So we're saying 2 sine theta plus 3 cos theta should be equal to r sine theta plus alpha. Alright, so what we can do here is to use the compound angle for sine to expand this and say that 2 sine theta plus 3 cos theta is equal to, this will become r, then we've got sine theta cos alpha plus cos theta sine alpha. Alright, so 2 sine theta plus 3 cos theta is equal to, multiplied through by r, so r sine theta cos alpha plus r cos theta sine alpha. And now we're going to write this as, I'll just put the numbers in red, you see why in a second, 2 sine theta plus 3 cos theta is equal to, and then here r cos alpha, and then we've got the sine theta plus r sine alpha, so r sine alpha, and then we've got the cos theta. So comparing the left and right hand sides, you can tell that it means 2 must be equal to r cos alpha and 3 must be equal to r sine alpha. So we can say that r cos alpha is equal to 2 and r sine alpha is equal to 3. So if we make cos alpha subject of the formula here, cos alpha is equal to 2 over r, and here you'd get that sine alpha is equal to 3 over r. And we can use this information that we have to draw a right-angled triangle. Alright? So we've got a right angle triangle here, right angle, and this angle would be angle alpha. So we know that cos is adjacent over hypotenuse and sine is opposite over hypotenuse. So it means our opposite side is going to have a length of 3, and it means our adjacent side has a length of 2, and our hypotenuse has a length of r. So now that we have this right angle triangle, we can now evaluate both r and alpha. So starting with r, we can simply use Pythagoras to evaluate r. R should be the square root of 2 squared plus 3 squared. So we get that r is equal to root 4 plus 9, which is root 13. And then to evaluate alpha, we've got the opposite and the adjacent. So we can say that tan alpha is equal to opposite, which is 3, over the adjacent, that's 2. Alpha is equal to arctan of 3 over 2. So alpha would be, in degrees, they usually tell you what unit to use. So in degrees, arctan of 3 over 2 gives you 56.310 degrees to 3 decimal places. So it means our expression 2 sine theta plus 3 cos theta can be written as r, which is root 13, sine theta plus 56.310 degrees. And so it means the equation that we have here on top would be, we just add equal to 1. And so we now have this equation, root 13 sine theta plus 56.31 degrees is equal to 1. And so we've now reduced our equation to one trig function, and so we can solve it like we would any other trig equation. Alright, perfect. So from this simplification, we can actually derive some formulas, because for r, at the end of the day, what we did for r is we took the square root of 2 squared plus 3 squared. At the beginning, I told you that this is a sine theta plus b cos theta. So we took the square root of a squared plus b squared. So the formula for r is going to be the square root of a squared plus b squared. This is assuming that you've got something of the form a sine theta plus b cos theta. B cos theta. And then for tan alpha is equal to, b was 3, this is b, this is a, b was 3, and a was 2. So we can say that tan alpha is equal to b over a. But this changes depending on whether you're moving to r sine or r cos. So this is specifically for r sine theta plus or minus alpha. Alright, well, we're going to do the derivation for r cos as well, just to show that this changes. So this specifically, tan alpha is equal to b over a, only works for r sine theta plus or minus alpha. You find that r is equal to root a squared plus b squared is consistent for both r cos and r sine. So we're going to take the same problem that we have, and on the side here, I want us to move to r cos instead of r sine. So this is 2 sine theta plus 3 cos theta. And we want to move to r cos. This time let's use the minus sine theta minus alpha. They will tell you whether you're using theta plus alpha or theta minus alpha. But in this example, let's use theta minus alpha. Alright, so that becomes 2 sine theta plus 3 cos theta. And we're going to use the compound angle formula for cos theta to expand this. So this becomes r times cos theta cos alpha. Be careful here, this becomes a positive sign. So sine theta sine alpha. And so if we expand, we've got 2 sine theta plus 3 cos theta is equal to r cos theta cos alpha plus r sine theta sine alpha. And so here This is 2 sine theta plus 3 cos theta is equal to, this is r cos alpha cos theta plus r sine alpha sine theta. So here we can tell that the coefficient of sine theta is going to be r sine alpha. So it means that r sine alpha is equal to 2, and the coefficient of cos theta is going to be r cos alpha. So we get that r cos alpha is equal to 3. So sine alpha can be written as 2 over r, and cos alpha can be written as 3 over r. And so again, we're going to draw our right angle triangle. Alright, so this would be angle alpha. We know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse. So our opposite is going to be 2, and our adjacent is going to be 3. Our hypotenuse is r. So r is going to be, again, the square root of 2 squared plus 3 squared using Pythagoras. So r is still root 13. The difference now comes in evaluating alpha. So for alpha, we're going to say tan alpha is equal to opposite over adjacent. So tan alpha is equal to 2 over 3. Alpha is equal to arctan of 2 over 3. So you get alpha is equal to arctan of 2 over 3. That gives us 33.690 degrees. So it means if we are writing 2 sine theta plus 3 cos theta as r cos theta minus alpha, this would be root 13 cos theta minus 33.690 degrees. Alright, and so now notice that we say this is written in the form a sine theta plus b cos theta. So for r, we can still say that r is the square root of a squared plus b squared. But for alpha, notice that tan alpha is now equal to a over b, whereas previously for r sine, tan alpha was b over a. So that's where we get the difference. When you are evaluating alpha for r sine theta plus or minus alpha, we use tan alpha as b over a. But if it's for r cos theta plus or minus alpha, we use tan alpha as a over b. Alright, so let's apply this to some past paper questions. So here we are told to express root 7 sine x plus 2 cos x in the form r sine x plus alpha, where r is greater than 0 and alpha is between 0 degrees and 90 degrees. State the exact value of r and give alpha correct to 2 decimal places. Alright, so we have root 7 sine x plus 2 cos x, and we want to write this in the form r sine x plus alpha. Okay, so we know that this is in the form a sine x plus b cos x. So we can start by evaluating r. R is going to be the square root of a squared plus b squared. So r is equal to root 7 squared plus 2 squared. So r is equal to, let's punch this into the calculator, that's the square root of root 7 squared plus 2 squared, and this gives us root 11. And then for alpha, we said under r sine, tan alpha is going to be equal to b over a. So tan alpha is equal to 2 over root 7. So this gives us alpha is equal to arctan of 2 over root 7 and so alpha is equal to arctan of 2 over root 7 gives us 37.09 degrees, correct to 2 decimal places. So this means root 7 sine x plus 2 cos x can be written as root 11 sine x plus 37.09 degrees. Alright, and so we have written this in the form r sine x plus alpha, and this is our final answer. Let's look at one for cos, r cos. So here we're told to express root cos x minus root 5 sine x in the form r cos x plus alpha, where r is greater than 0 and alpha is between 0 degrees and 90 degrees. Give the exact value of r and the value of alpha, correct to 3 decimal places. So we've got root 2 cos x minus root 5 sine x. Alright, so we want to write the sine x first, so that's negative root 5 sine x plus root 2 cos x. Alright, and this should be equal to r cos x plus alpha. So here it means that a is going to be root 5 and b is going to be root 2. You can ignore the negative sign here because when we expand r cos x plus alpha, we're going to get r cos x cos alpha minus, because of the way the compound angle formula for cos works, this is going to be minus r sine x sine alpha. Alright, and so if we rewrite this properly, you're going to have, so this will be r cos alpha cos x minus r sine alpha sine x. So you can tell that the negative sign comes from the formula. So it means r sine alpha itself is just going to be equal to root 5, and r cos alpha is going to be equal to root 2. So you can ignore the negative sign. So to get r, we're simply going to say the square root of a squared plus b squared. R is equal to the square root of root 5 squared plus root 2 squared. So r is equal to, let's punch this into the calculator. This is going to be root 5 plus 2, so root 7. And then for alpha, we're going to use tan alpha is equal to a over b. And so this gives us tan alpha is equal to, that our a is root 5 and our b is root 2. So alpha is arctan of root 5 over root 2. Alpha is equal to, let's punch this into the calculator, arctan of root 5 over root 2. This gives us 57.688 degrees, correct to 3 decimal places. So it means we can write this expression as root 7 cos x plus 57.688 degrees. Alright, so those are harmonic identities and this is how they work.